Hello everybody, my name is Rishi. Today we'll be going through the first problem in DeepML, which is matrix vector dot products. It's a linear algebra problem and it's ranked easy. So the task is to write a Python function that computes the dot product of a matrix and vector. The function should return a list representing the resulting vector if the operation is valid, or -1 if the dimensions are incompatible. A matrix can be dotted with a vector, a list, or only if the number of columns in the matrix equals the length of the vector. So if we have an n by m matrix, then we need a vector of length m to dot product it. The input matrix is a valid list of lists. The vector is a non-empty list. Okay, so before we get to code, it's good practice to walk through and list down what we need to do. So requirements. So what do we need to do? We need to return a torch.tensor of the dot product between matrix A and vector B. We need to take in a list slash array or a tensor and check for dimension mismatch between A and B. And then we need to compute the dot product. Okay, so now that we have that plan, let's sketch out how this would look. So input A, which is list, array, or torch.tensor, and B, a list representing a vector. Okay, now from that we need to check for dimension mismatch. So if dimension mismatch, then what do? We return -1, but we have to return a tensor of -1. Okay. And that connects here. Cool. Now, next thing we do is compute the dot product, of course. So, compute the dot product between A and B. And then the last thing we do is return the dot product. So, return the dot product. Okay, so how would we implement this in PyTorch now? And yeah, I'm coding in PyTorch. So first things we do, we have matrix A and vector B. So we need to, first of all, convert them to a tensor so we can actually check for dimension mismatch because we have to return a torch.tensor. So I actually need to put the step in here to convert to tensor. And this can slot in like over here, I guess. Okay, it's a bit messy, but I think the general point gets across. So we need to convert matrix A and vector B to tensors. So how do we do that? So we can say A of t standing for tensor, is a torch.asTensor, a function that lets you convert anything to tensor. And let's set the dtype to torch.float. We're going to set the dtype so that way both A and B have the same dtype when I set B equal to torch.asTensor of B comma dtype equals torch.float. And that prevents any errors regarding data types when the dot product gets calculated. So that's the second step after we get the input. Now next step is check for dimension mismatch. So if what? Well, we need to check if the columns of A are not equal to the size or like the length of B. So way to get the columns of A is dot size function, and size returns for matrix A rows comma columns. So if we index it on 1, then we get this gives us the columns of A, which is what we want. So if the columns of A are not equal to what? Well, we need to see if they're not equal to the length of B, as in like length M from this example over here. So that would be the size of B. And B is just rows, so size 0 just gives us the rows of B, which is the length of the vector. So when we have this, what do? We return a tensor of -1. So we can't do this. We have to return torch.tensor -1. So now the last step is compute the dot product. And a helpful PyTorch function for this, or like notation for this, is the @ symbol. It stands for matrix multiplication, and it computes the dot product. So this equals dot product. But instead of just like setting this equal to a variable and like returning it like so, it's easier to just skip the variable entirely and return the calculation alone. So compute and return the dot product. Okay, and that should work. We'll see any errors if they come up and fix them. Okay, and it passes both test cases. So you can see the first test case we have 1, 2, 3, 2, 4, 5, 8, 6, 8, 9 as the matrix and vector of 1, 2, 3. And the dot product there is 14, 25, 49. Yep. And also, noticeably, our D types match the expected D type, which is, nice. Second, test 2 is checking for the mismatch, which we got correct because we returned a tensor of -1. And this is important because it prints the result.numpy.toList. So if we just return -1, then that would not be correct. But returning a tensor means that it actually converts it to an array in NumPy, which would then be correct. Okay, thank you all for watching, and see you next time.